Well, hi there and welcome, Calculus 221 students. We are going to be looking at the derivative in this chapter, but first off, we're going to start with a review of the slope. So this section 1 video will be just a review on different aspects of the slope of a line. If we look first, our equations of our non-vertical lines, we will see that a non-vertical line, we'll call him L, has an equation of the form y equals mx plus b. Now this number m is called the slope of L, and the point 0b is called the y-intercept. The equation that we are looking at, this y equals mx plus b, is called the slope-intercept equation of our line L. An example of this would be y equals 3x minus 4. And for this particular example, our slope, m, equals 3, and our y-intercept equals negative 4. So we're going to look at how to use this. Now the following graphs are equations of lines that have positive slopes. And we are looking at a graph where if I go left to right, I see that I am going uphill. If I look at this first line, I will see that my slope is 2, y equals mx plus b, so my slope is 2, and my y-intercept would be negative 1. You can notice if I were to graph this, draw a point on the y-axis at 1, and I would go up to 1, 2 over 1. And that's my slope. On this one, my slope is once again 2, and my y-intercept in this case is 0. So I draw a point here at 0, and I would go up 2, run 1, and there is my line. Another example, still the slope is 2, and in this one the y-intercept is 1. So I draw my y-intercept at 1, and I could say I'm going up 2, running 1, and I would create that line. You'll notice all these lines have the same slope but different y-intercepts. All right, let's play the same game, but in this case, I'm going to look at slopes that are going downhill. Notice the slope is negative 2. The slope is the number that's next to the x, and the y-intercept in this case would be negative 1. Notice negative 1, the slope is negative 2, go down 2, run 1. Notice if I read this graph from left to right, I see that I'm going downhill. Very similarly, the slope is negative 2. See how all the steepnesses of these lines are the same? And the y-intercept is 0. So if I were to graph it, I would just say y-intercept is 0, down 2, run 1. Likewise, slope of negative 2 for this next line, and a y-intercept of 1. Cool. All right, let's look at this example where we're talking about pay. I need to figure out what x and y are anytime I'm looking at a word problem such as this. And we're going to be looking at quite a few word problems. This is an applied calculus class. So we have x units of goods. So x is the number of goods. And the pay is y equals 5 times the number of goods plus $60. So this is what her weekly pay depends on. So it looks to me like if she sells 0, her weekly pay is 5 times 0 plus 60. So she sells nothing. Her weekly pay is 60. Therefore, we have the point 0, 60. Let's do another point. Say if x is 80. If x is 80, say she sells 80 of these items. It's 5 times 80 plus 60. I would then get $460. So if she sells 80 of these goods, she'll get $460. So in graphing this, I see that I have my point 060, and then I also have my point 80 at 460. And what this really means, since the slope is 5, so let's write that down. the slope is 5, then we have m equals 5 and b equals 60. So that means that for each sale, each item of goods or whatever it is, she gets $5. And no matter what, her base pay is going to be 60. All right, these are a couple of properties of slopes that you've been through over the years. And let's just look at this slope property 1. Suppose you start at a point on a line and this slope has a slope of m, or the line has a slope of m, and you move 1 unit to the right, and then you would move 1 up. This would give you a positive slope. If you have a slope of m and you move 1 unit to the right and then down, that would be a negative slope. There's also horizontal lines that we have to consider, and that is where you don't go up and down, but you just keep moving to the right. Slope property 2 defines slope in terms of an equation, and this is the equation that we have been looking at for many, many years now. We can compute the slope of any line as long as we know 2 points on that line. If x1 and y1 and x2 and y2 are both on that line, then the slope of the line is given. M equals y2 minus y1 all over x2 minus x1. And then we can see from our graph here the slope of the line. Another important property that we're going to look at is the point slope form of a line, and we will use this point slope form of a line over and over. The equation of a line can be obtained if we know the slope and 1 point on the line. There it is. Here's the slope and 1 point on the line. If the slope is m and the point x1, y1 is on the line, then we are given the equation y minus y1 equals m times the quantity x minus x1. This equation is called the point slope form of the equation of a line. Slope property 2. Distinct lines that have the same slope are parallel. Conversely, if 2 lines are parallel, then they have the same slope. Slope property 5, when 2 lines are perpendicular, the product of their slopes is -1. We also say that these slopes are negative reciprocals of each other. So write that down there, negative reciprocals. So that means if the slope of one line is 2, then one perpendicular to him would be -1/2. Those are negative reciprocals of each other. Sometimes we're given an equation and not a real pretty form. We would like for it to read y equals mx plus b. So we're asked to find the slope and the y-intercept of the line y equals x plus 1 all over 3. So we can bust this fraction by distributing the 3 so that we have y equals x over 3 plus 1 over 3. Furthermore, we can look at our very first term, this x over 3, and rewrite it as 1/3 x plus 1/3. This gives us a slope of 1/3, y-intercept of 1/3. That's cool. They both ended up being the same. Doesn't have to be that way, but this is a coincidence for this one. They've asked us to sketch this particular line, so let's do that. I need a few tick marks on here so that I can draw this. And it says that we have a point, -1, 1. So I'm going to draw that point in a different color. So let's do an ink color, this blue. -1, 1. There's that point. The slope is 1/2. So I'm going to rise 1 and run 2. 1, 2. So I have this line. Looks like this. Now it might be a little bit tricky on my math lab to get this to draw first. So you're going to have to practice with the graphing tool. but after a while you'll get the hang of it. Just go ahead and suffer through it and watch the video on how to do graphing on MyMathLab. It'll be worth it in the long run. We're asked to find the equation of a line that passes through the points -1/2, 0, and 1, 2. I'm going to use my point slope formula. Here he is. It's y minus y1 equals m times the quantity x minus x1. Well, I'd like to know that, but I don't have the slope, and I don't have, well, I have 2 points. Hey, you know what? I could use this y2 minus y1 over x2 minus x1, because that is the equation for slope. I'll call this point 1, this point 2, and I will plug that into my slope formula. So that gives me, let's see, y2, that's 2, minus the y value from point 1, that's 0, over x2, that's 1, minus a -1/2. Doing our computation here, I'll get m equals 2 over 1 minus a -1/2 happens to be plus, so 1 plus 1/2 is 3/2. And flipping this fraction and working with it, that gives me 2 divided by 3/2, so I'll flip and multiply, so that's going to be 2 over 3. This is going to equal 4/3. So the slope is 4/3. Choose any point. I happen to like this one. Y minus, I need the y value from that point. That's 0 equals 4/3 times x minus the x value from that point 1, so that's -1/2. What I end up with, if I simplify, distributing this 4/3, and then plus, and then I need to do 4/3 times 1/2. So that's going to be 4 over 6, or 2 over 3. And that is the equation of a line that passes through that point. Once again, I'm to find the equation of a line that passes through a point. So I know a point, and it's perpendicular to this line. Well, it doesn't quite give me the slope that I want. I know I'm going to use this y minus y1 equals m times x minus x1. I know I'm going to use that. So I need the slope of my line. I actually have 2 lines here. I have a line that goes through a point 2, 0, so that's 1, 2, 0, and a line that looks like y equals 2x. So there's the y equals 2x line. So this is my y equals, 2x line. So the slope for this line is m equals 2. So I have a line that goes through this point but is perpendicular to that guy. So it actually, my new line is going to look somewhat like this. So this is the line that I'm actually looking for. I want this one, y equals whatever. So since I know that these 2 lines are perpendicular, I can say that the slope of this line happens to be, write down m equals -1/2. Cool. And I can use this point slope formula, and I would get y equals, sorry about that, let me write down minus my y value from my point, which is 0, equals -1/2 times the quantity x minus 2. So y equals, distributing, -1/2 x, and then I have minus minus, so it'd be plus 1/2 times 2 is 1. So there is my equation for that line. Right, I went to Desmos and I graphed this for us so we could look at what's going on. They asked us to look at what the rate of change was over the interval from 0 to 1. So I had to make this graph, had to zoom out so we could see all of it. But they want to know what the rate of change is from about here to here. So from there which that point is 0.27. Right there in the middle. Get that point. Okay, 125. And how we'll do that is we just find the slope. That's keyword for rate of change, just means slope. So we'll do that. What is the slope of this line again? Well, it looks like it is reading from a graph -2. So while at first it might look like a strange question because you're trying to figure out what in the world does it mean? Why do I have those intervals? This is basically two separate problems. I'm supposed to find the slope over this interval and then the slope over this interval. So for x somewhere an element of this interval here, I know that the slope is, well, let me rewrite that thing, y equals -2x plus 27. The slope is -2. And since we have a line and I know the slope doesn't change for x in this interval, or an element of 0 to 0.5, the slope is also -2. What you can do if you want to work the algebra of it, but we don't really need to because this is a line, is I would get the 2 points. So for x equals 0, so if x is 0, y is plugging that in, y is 27. If x is 1, plug in a 1, that would be 25. And then you could do the slope formula, which m is y2 minus y1 over x2 minus x1. Plug all of that in and get, we'll let this be 0.1 and this be 0.2. And then I would say that that would be 25 minus 27. And then I would say 1 minus 0. If I compute this, I will get -2, which we already knew. And you would do the same thing for this one if you wanted to work the algebra and prove that the slope was -2. And that's all for section 1.1. If you have any questions, be sure to send me an email and I'll work through any problems for you that you want. I will definitely be available for collaborate, be anxious and excited to do that for you. Just email me and let me know how I can help you. Thank y'all. Have a wonderful day.